Welcome to my class. In this video we are going to be discussing about viscous flow related problems, Stokes law and terminal velocity related problems, poiseuilli's equation when two capillary tubes are connected in series and parallel combination. That related problems we are going to be discussing. Here the first question says a metal plate of area 400 centimeter square on glycerin layer of thickness is given as 5 millimeter and coefficient of the viscosity of the glycerin is given as 2 Pascal second. The horizontal force required to move the plate with a velocity 5 centimeter per second. Here what we require to calculate in this question is the horizontal force which you require to move the plate. According to the viscous force concept, here viscous force acting on a body is Fe equals to, we can write it as minus eta into A into dV by dx we can write. Now here you are placing a metal plate, you are going to be placing on a glycerin layer. This is a glycerin layer, just imagine, and here its area is given as 400 centimeter square it's given. And here you are applying some horizontal force. This is a force you are applying to move the plate with a velocity of 5 centimeter per second. Here F which will be equal to, here we just calculate the magnitude of the force value so that I am not bothering about the sign. So here coefficient of the viscosity is given as 2 Pascal second is given and area of the plate is given as 400 centimeter square. So 1 centimeter equals to, you can write it as 10 power minus 2 meter. 1 centimeter square in the sense here you can write it as 10 power minus 2 meter whole square, which is nothing but 10 power minus 4 meter square you are taking. And here that value you can take 10 power minus 4 into 5 into, this is velocity is given as 5 centimeter per second. You need to convert 5 into 10 power minus 2 by, you can write it as thickness is given as, this thickness of the glycerin layer is given as 5 millimeter is given. So thickness of the layer is given as 5 millimeter, that you have to put instead of dx 5 into 10 power minus 3. Here 5 gets cancelled, 10 power minus 2 and here 1 10 power minus 2 gets cancelled and here 10 power minus 1 and here 10 power 2 and here 1 10 power minus 2 gets cancelled, 10 power minus 2 will be left over. And here 10 power minus 1 and here 10 power minus 1 gets cancelled. So here it says here F equals to, you will be getting as 2 into 4, it's an 8 you will be getting into 10 power minus 1. So which is nothing but 0.8 newtons you are taking. So here the required horizontal force is to move the plate is 0.8 Newton is the correct answer. Now look at the next question here. If the shearing stress between the horizontal layers of the water, it is given. So here 1.5 millinewton per meter square. Coefficient of the viscosity of the water is given 1 into 10 power minus 3 Pascal second. The velocity gradient they are asking. So velocity gradient is nothing but, according to the viscous force formula, F equals to, you can write it as, so magnitude of the viscous force which will be equal to eta into A into dV by dx. Here the required velocity gradient means, so change in velocity per unit height or unit distance. So which will be equivalent to, here you can write it as F by A into eta you can take. So here the shearing stress, here it will be acts along its tangential surfaces. Shearing stress doesn't mean, here you can write as force acting per unit area along its tangential surfaces. So viscous force is a tangential force you are calling. So force acting per unit area already it's given. Here it's a 1.5 millinewton per meter square. So instead of F by A, here you have to put this value. This is 1.5 into 10 power minus 3 millinewton per meter square by, instead of eta it's given as 1 into 10 power minus 3 Pascal second, that you have to take. 10 power minus 3, 10 power minus 3 gets cancelled. So here you have to take, it's a 1.5 you will be getting. So velocity gradient dV by dx value will be 1.5 per second we will be getting. This is per second. So this will be the correct answer. Now look at the next question. A force of 10 Newton is required to draw a rectangular glass plate on the surface of the liquid with some velocity. Force needed to draw another glass plate of the 3 times of the length and 2 times of the width they are given. Force required to draw the rectangular glass plate, F equals to here viscous force acting on a plate, which will be equal to eta into A into, you can take as dV by dx. So here they have given us, they are going to be changing the area 3 times of its length. Here initially you are taking as, here this is a plate you are taking, rectangular plate, and here length and as well as width you are going to be changing like this. Here you are going to be changing like this. So here it becomes 3 times of its length is given, L dash equal to 3L, and here its breadth is given as B dash equals to, here it's given as 2 times. Initial length you can take as L, you can take, initial breadth you can take as B, you can take. So according to viscous force acting on a body, formula will be F equals to eta into A into dV by dx. They are not talking about the other factors. Here you can take it as constant all these things, here eta and us. So F is here, how it is related to the area means directly proportional to the area I will be getting. We require the second force, already first force value it's given. So you can take the ratio F2 by F1, which will be equal to A2 by A1, you can do. F2 by F1 is given as 10 Newton, which will be equal to A2 in the sense here we can take as 3 times of its length, and here 2 times of its breadth is given by initial length is L, initial breadth you can take as B, you can take. LL gets cancelled, L and B. Here we will be getting as 6 will be getting. So the required force F2 value will be getting as 10 into 6 newtons. So which is nothing but 60 newtons you are getting. So this will be the correct answer. Look at the next question. Next question says, a square plate of 0.1 meter side moves parallel to the second plate with a velocity of 0.1 meter per second, it's given. Both the plates being immersed in a water if the viscous force is given as 0.2 newtons and the coefficient of the viscosity is given as 0.01 poise. Coefficient of the viscosity is given as 0.01 poise, it's given. Here 0.01 poise, here this is a poise. So you know here 1 Pascal second, which will be equal to 10 poise will be taking. 1 Pascal second, this is a relation between the CS and SI unit of the coefficient of viscosity. 1 Pascal second equals to 10 poise you are taking. So here then 1 poise is nothing but, here you can get it as 1 poise is nothing but 10 power minus 1 Pascal second you can take. Why? Because in the question they are asking, so if the viscous force is 0.02 newtons and the coefficient of the viscosity is poise, distance between the plates in meters they are asking. So we need to convert all the units into SI system. So here the required force is F equals to eta into A into dV by dx. So here we require to calculate the distance between the plates is nothing but dx we need to calculate, which will be writing as here eta into A into dV by, you can take as force you can take. Now here you have to take the units and other things. Eta is given as here coefficient of the viscosity is 0.01 poise is given. Poise I am just converting into Pascal second, 10 power minus 1 into area it's given as here this is area of the plate, how much it is given. Here a square plate of 0.1 meter side is given. Here square plate of 0.1 meter is the side is given. So A in the sense here you can take it as this is 0.1 into 0.1 you can take. Here you will be taking 0.01 you are taking into dV. Velocity is given as here 0.1 meter per second is given, that you have to take by, you will be writing as force you are applying as viscous force acting on a body is 0.002 newtons it's given. Now you have to take this one 0.01 we can write it as 10 power minus 2 into 10 power minus 1 into this one you have to take it as 10 power minus 2 the next thing, and here you can take it as 10 power minus 1 by, and here you can take it as 2 into 10 power minus 3 here 10 minus 2, here you just add all these things here, 2 plus 1 3, 5, 6 will be getting, and here this 6, and here it will be minus 3 here to gets cancelled, and sorry, here it becomes 10 power minus 3 numerator you are getting. This is when you are cancelling here, you will be getting as 10 power minus 3. So 1 by 2 into 10 power minus 3 will be getting. So 1 by 2 is nothing but will be taken as 0.5. 0.5 into 10 power minus 3, you can write it as 0.0005 meters is the correct answer. So fourth one is the correct answer. Next, look at here, when a body falls in the air, the resistance of the air depends to a great extent on the shape of the body. Three different shapes given. Identify the combination of the air resistances which truly represents the physical situation. So here different aerial bodies is given here, which is falling on the medium. Now here which one will experience the greater resistive force they are asking. Now in actually here in a streamline flow, here you can take in a streamline flow whose surface area is maximum, then it will experience or else that body you can take, that body will experience minimum resistive force. So here among these three bodies here, right, area will be more for this disc, and here when compared to this ball, and here it will be more will be getting than the cigar shaped one. So here obviously here, so which one it will experience is the right resistive force in order. If it is your talk in the sense, here you can write as third body, it will experience the right less resistive force, so that you can write as 3 is less than, 2 is less than, here will be getting as 1 will be getting. So this will be the correct answer. Look at the next question. A glass plate of surface area 1 meter square is placed on a layer of a turpentine of the thickness is given as 2 millimeter. If the coefficient of the viscosity is given as 0.00149 Newton second per meter square, the force to be applied to move the plate horizontally with a velocity of 0.1 meter per second is. So here they require the horizontal viscous force they are asking to move the plate horizontally. F equals to, here eta into A into dV by dx you can take. So here coefficient of the viscosity is given as 0.00149 it's given. It's in SI unit is given Newton second per meter square, into area is given as 1 meter square is given. With what velocity you are removing the plate in the sense 0.1 meter per second by dx, thickness of turpentine layer it's given as 2 millimeter. 2 into 10 power minus 3 you can take. Here even we can write this one as here 1, 2, 4, 5. Here we can write it as 149 into 10 power minus 5 you can take into, this is 10 power minus 1 by, you can write as 2 into 10 power minus 3. Here minus 3 and here minus 3 gets cancelled, remaining will be 10 power minus 2. Here 149 by 2 in the sense here you will be getting nearly all together here the answer will be getting as 0.0745 newtons will be getting. So this will be the correct answer. Look at the next question. In the flow of viscous fluid over a flat horizontal surface, the velocity is given as 0.5 centimeter per second at 1 millimeter distance above the flat surface at rest. So what is the velocity gradient they are asking? So here in the flow of viscous liquid, here a horizontal surface, the velocity is given as 0.5 centimeter per second. So velocity gradient, the formula will be velocity gradient, which will be equal to, will be taken as dv by dx, it's given. So here above the flat surface which is at rest is given. So here you can take final velocity minus initial velocity you are talking means. Here you can take as initial velocity, you can take as 0.5 centimeter per second. You have to convert 0.5 into 10 power minus 2, and the second velocity you have to consider as 0, and here thickness of the layer you have to take as 0. Here it's given as 1 millimeter is the distance is given. So here we would like to convert 1 millimeter distance dx value. So this is the dx is given as 1 millimeter distance is given. Now 1 centimeter equals, will be writing as 10 millimeter. In options they are asking in terms of the centimeter dx value they are expecting. So here you can take as 1 millimeter you have to take as 10 power minus 1 centimeter you have to take. So here I am just taking as this one as 10 power dx value you can take as 10 power minus 1 centimeter you can take. So here 0.5 by 0.1 you can take as 5. So you can write it as 5 into 10 power minus 2. So you can write it as 0.05 meter per second is the velocity unit, and here this one already we have converted into centimeter. So meter per second, centimeter you can take, per centimeter you have to take, per centimeter. Velocity units will be meter per second, and dx thickness units we have to take in centimeter. Why? Because they are asking in options as in centimeters. So 0.05 meter per second per centimeter. So now we can discuss about Poiseuilli's formula and arrangement of the capillary tube related problems. Here the first question says water is flowing through a capillary tube at the rate of 20 into 10 power minus 6 meter cube per second. Another tube of same radius and double the length is connected in series to the first tube. Now the rate of flow of water they are asking. So here two capillary tubes is given. One here it will be, here you can say this is a one capillary tube you are taking, and its length is given as L is given, and here one more capillary tube also you are going to be connecting. This is another capillary tube you can take. So double the length is given. Here this length will be double it's given, and here it's connected in series you are connecting to the first tube. So here another tube of the same radius. Here both the radius will be same you can take. This radius and this radius will be same you are taking. Now here the rate of flow of water in meter cube per second they are asking. Here you just look at here volume of the liquid flowing per unit time according to the Poiseuilli's V equals to, you can write as pi by 8 into P r power 4 by eta into L you are taking. P is nothing but pressure difference between the two ends of the tube you can take, and here in series when you are connecting, here in series how much volume is flowing across this tube, and the same volume is going to be flowing across the second tube. So here you can take in series volume of the liquid flowing per unit time, it remains same you will be taking. So here this is, let us take it as V1 you can consider, and the second tube when you are considering second tube, be remember it's a combination of the two tubes. So you must talk about the combination of the two tubes length. So here you can take it as pi by 8 into P r power 4 by eta into total length after connecting in series will be 3L will be getting. So when you are relating V1 and V2, V2 equals to, you will be writing as V1 by 3 you are taking. So here V2 which will be equal to V1 already it's given. How much volume it is flowing? 20 into 10 power minus 6 by, you can take as 3 you can take. So nearly this value will be writing as 6.67 into 10 power minus 6 meter cube per second will be writing. So here this will be the correct answer. Look at the next question. An artery in a certain person has been widened 1.5 times the original diameter. If the pressure difference across an artery is maintained constant, the blood flow through the artery will be increased. So here an artery is given, here it is widened, right? 3/2 times it is going to be widened. Now here they are asking how many times here, if the widened means here how many times the volume will be flowing. According to the poiseuilli, volume of the liquid flowing per unit time is V equals to, you can write as pi by 8 into P R power 4 by, you can write as eta into L, you can take. Here volume, how it is related to the radius, in the sense here V is directly proportional to, here you can write as R power 4, you can take. So here we would like to calculate the final volume when it is widened, right, 1.5 times. So here you can say here V2 by V1, which will be equal to, you can write as, it's an R2 by R1, right, R2 by R1 whole power 4, you can talk. R2 is nothing but, D is nothing but, here will be taken as 2R will be writing, then R equals to, you can write as D by 2. So R is directly proportional to D, you can take in numerator and denominator 2 you have to eliminate. So here we can take directly in terms of radius, directly radius also you can take. So here you can take as 3/2 times of the radius by initial radius, it's given as R is given whole power 4, you can take. So here when it comes to the numerator, here V2 by V1, which will be equal to 3R by 2, this R it will comes to the numerator by this R will be getting whole power 4. R gets cancelled, so V2 by V1, which will be equal to, this is 81 by 16 will be getting. So V2, which will be equal to, you can write as 81 by 16 times of V1 will be getting. So fourth one is the correct answer. Look at the next question. The next question says water flowing from a hose pipe fill up to 15 liters container in 1 minute is given. The speed of the water from the free opening of the radius 1 centimeter is. So here across a hose pipe, now it's going to be filling the container. Here this is the hose pipe you have to take. Here now here it's going to be filling the water. So here this is a container you can take. Here you are filling the container. The speed of the water from the free opening of the radius 1 centimeter is here. Suppose here if the radius will be 1 centimeter, then here the speed they are asking. Here volume of the liquid flowing per unit time, according to the equation of continuity, the formula will be area into its velocity you are taking. Area of the tube, in the sense here you can write as pi r square into, you can write as velocity will be V. How much volume it's given means here 15 liters is given. 15 liters of the volume. This is V is nothing but, capital V is nothing but volume of the liquid flowing per unit time. This is liter, I am just converting into 10 power minus 3. Unit time, in the sense here the time is given as, here 1 minute is given, you have to convert into 60 seconds, which will be equal to, you have taken as pi into R is given as across the area of radius 1 centimeter. You have to convert this one. Here 1 centimeter square means 10 power minus 4 meter square into, you can write as velocity will be V. So here you have to cancel this one. Here you'll be writing as 10 power minus 3, and here 10 power minus 3 gets cancelled. Here it becomes 10 power minus 1. So the velocity will be 15 by, here you can write as pi into 60 into 10 power minus 1. Here 10 power minus 1 and plus 1 gets cancelled. Here you can write as 3 5z, 3 2z you are taking. 5 by 2 is nothing but, here you can write it as 2.5. In denominator pi will be there. So this is the 2.5 meter per second you are taking. So this will be the correct answer. Now look at the next question. Two liquids are allowed to flow through the capillary tubes of lengths or in the ratio is given as 1:2, and the radius ratio is given as 2:3. So the thing is here two capillary tubes of length ratios is given L1:L2, which will be equal to, it's given as 1:2, and radii ratios is given R1:R2, it's given as here 2:3 you can take, or else you can take, right, under the same pressure difference, if the volume rates of the flow of the liquids here, volume rates they have taken, means the amount of the volume flowing per unit time it's given, V1 by V2 is given as 8:9 it's given. The ratio of their coefficient of the viscosity is here. This is the question here we need to calculate. So here the ratio of the coefficient of the viscosity means eta1 by eta2 they require the ratios. Here volume of the liquid flowing for unit time, the formula according to the Poiseuilli is pi by 8 into P into R power 4 by, here you can write as zeta into L, and here pi by 8 of course is a constant value, pressure difference is given as same is given. Now here you have to relate the eta, R, L and as well as V values. So here I am just relating as eta, which is directly proportional to, you just cross multiply this one. Eta is directly proportional to, here we can write it as R power 4 by volume of the liquid flowing per unit time into length you can write. Then eta1 by eta2, which you can write it as R1 power 4 by R2 power 4 into, here you can write as V2 by V1 into, you can write as L2 by L1 you can take. R1 by R2 whole power 4 means ratio of the radii is given as 2:3. 2 by 3 whole power 4 means 2 power 4 means 16 by 3 power 4, in the sense here we will take as 81. Volumes ratio it's given as, so here V2 by V1, you just reverse this one, here we'll be getting as 9:8, and L2 by L1 ratio will be getting as 2:1. So here this is 990, 240 and 440 will be getting. So the ratio will be getting as 4:9 will be getting. So the coefficient of the viscosity's ratio will be, this is 4 and here it will be 9 will be left over. So 4 by 9 is the correct answer. The next question says the viscous resistance of the tube. The viscous resistance of the tube to liquid flow is R is given. Its resistance for a narrower tube of same length is given and 1 by 3 times of its radius is given. So here the resistance, here they are talking about the resistance. So according to the Poiseuilli, volume of the liquid flowing per unit time is pi by 8 into P R power 4 by, you can write as zeta into L. This one even you can write it as P by 8 eta L by, here you can write as P R power 4 you can take. So here this one will be calling as fluid resistance will be called. Your R value here what you can take, R is nothing but here 8 eta into L by P R power 4. So the question they are asking us, it's a resistance for a narrower tube of same length but 1 by 3 times of the radius they are asking. Now here you just relate the resistance value with the length. Length of course is a constant value. Here how it is related to the radius means here it is R power 4. So R, when you are relating to the radius value, which is R is directly proportional to the R power 4. Capital R is the resistance value, small r is the radius. Now you just calculate the final resistance value. That means here R2 by R1, which you can write it as R1 power 4 by, you can write as R2 power 4 you can take. So here R1 you can consider as R you can take. R2 it becomes here 1 by 3 times of the radius. So R2 here it's given as R by 3. R by 3 you have to take, whole power 4 you can take. So here when it comes to the numerator 3, here this RR gets cancelled. Then R2 by R1 is nothing but R. 3 power 4 in the sense here you can write as 81. So R2 final resistance value will be 81 times of the initial resistance you are getting. So this will be the correct answer. Look at the next question here. 3 horizontal capillary tubes of same radii and lengths will be L1, L2, L3 is given, are fitted side by side in a little above the bottom to the wall of the tank. So that is filled with the water it's given. So here you are taking as a water tank, you are taking here like this. You are fitting 3 capillary tubes of a different lengths it's given. One capillary tube you just take like this. Here there's a base you have to take. Another capillary tube you are fixing like this. One more capillary tube you are going to be fixing like this. Here all the lengths will be given as here L1, and here it is L2, and here it is given as L3 it's given. So the length of the single capillary tube of the same radius. Here all the radius you can take as right, R you can take. So now instead of these three here, you are going to be replacing one more tube of the same length. The length of the single capillary tube of the same radius, that of the replaced, be 3 tubes, such that the rate of flow of water through the single tube is equal to the combined rate they are asking. Now here instead of these 3 tubes, you are going to be replacing one tube of the same length and as well as radius is given. Length will be same and radius will be same. Then see the question clearly. Here it is mentioned as 1 should be replaced by the 3, so that here volume of the liquid flowing per the single tube, which will be the combination of the volume of the liquid flowing across the all the 3 it's given. So V, which will be equal to, here you can take as, here among these 3 here, volume of the liquid flowing per unit time, the formula will be pi by 8 into P R power 4 by, you can take as eta into L. In all the 3 here, you can take as common as pi by 8 into P R power 4 by eta, you can take common, into 1 by L1 plus 1 by L2 plus, here you can take as 1 by L3 you can take. So instead of V here, a single tube you are going to be replacing, that you can take pi by 8 into P R power 4 by, here 8 eta into, here you can take as L is the effective length, L is the single tube length you can take, which you can write it as pi by 8 into P R power 4 by eta into, so it's a 1 by L1 plus 1 by L2 plus, here 1 by L3 you are taking. So pi by 8 P R power 4, here pi by 8 P R power 4 and eta gets cancelled. Then 1 by L, which will be equal to, you can write it as 1 by L1 plus 1 by L2 plus 1 by L3 you can take. When you are taking the LCM, here you will be getting as L value, here you can write it as, by taking LCM, here it will come to the numerator, it's nothing but L1, L2, L3 by, here you can say as L1, L2 plus L2, L3 plus, here you can take as L3, L1 you can take. This is an effective length you are talking. Look at the next question. A liquid flows through 2 capillary tubes and fitted horizontally side by side to the bottom of the vessel containing the liquid. Their lengths are in the ratio is given as L and 2L, and the radius are in the ratio will be R and 2R respectively. If V is the volume of the liquid that flows through the first tube in 1 minute, now they are asking the time required for the same volume of the liquid flowing through the second tube they are asking. Here 2 tubes it's given. Here this is the first tube you have to consider, and this radius you can take as some R you can take, and here this length I am taking as L, I am just talking. You are connecting to the another tube. This is another tube you just take. Of this radius is given as 2R it's given, and you are connecting like this. This radius will be given as 2R it's given, and here this length will be L is given, and here this length will be 2L is given. And here when they are connecting in series, here the volume of the liquid, how much it is flowing across the smaller tube, the same volume is going to be flowing across the second tube in series combination. Now here you can take volume of the liquid flowing per unit time, the formula will be volume of the liquid flowing per unit time. They are talking about the time required, so you must mention the time value here. It's a pi by 8 into P R power 4 by, here you can take as eta into L you can take. So here I am just relating the factors which I know. Here length is given and radius is given. So here time they are asking. If V is the volume of the liquid that flows through the first tube in 1 minute, then second tube they are asking. Now here you can say time I am just relating to the given factors. 1 by T, which is directly proportional to R power 4 by, you can take as L, you can take. That doesn't mean here T is directly proportional to, here you can take as L by R power 4, you can take. Now here you can say the ratios, if you are taking T2 by T1, which will be equal to, here you can take as L2 by L1 into, you can take as R1 power 4 by, you can take as R2 power 4. Second length is given as 2L is given, 2L by L you can take into R1 power 4, means here you can take as R power 4 by, so 2R power 4 means here, this is 2 power 4 means 16, 16 R power 4 you can take, R power 4 gets cancelled, length gets cancelled, 2 how many times? It is 8 times it is going. Then T2 by here, first time it is taking here 1 minute, which will be equal to, you can take as 1 by 8. Then T2, which you can take as 1 by 8 minute is the correct answer. T2 equals to 1 by 8 minute. Look at the next question here. The rate of steady volume flow of water through a capillary tube is given as R. Under a pressure difference of P is V is given. The tube is connected with another tube of same length but half of the radius in series. Then the rate of steady volume flow through them they are asking. Here volume of the liquid flowing through the tube is V equals to, you can write it as here P by R you can write in unit time, where R equals to, here you can write it as fluid resistance you can write, that is nothing but 8 into eta into L by, you can write as pi R power 4 you can write. Then this is the resistance, you can talk initial resistance value. Now here this tube, now you are connecting with another tube of same length but half of the radius you are connecting in series. So when you are connecting in the series here, what are the other resistance value? Let us take here, if you are taking this is R1 and R2, first you have to calculate. When radius is half means here whatever the radius value, that means here 8 eta into L by pi into, you can write as R by 2 whole power 4 you can take, which is nothing but you can write it as 8 into eta into L by 16 into eta into L by, so you can take it as, this is here you can write as 16 into, this is 8 eta into L by, you can write as pi into R power 4 will be writing. It's nothing but here we'll be getting a 16 times of the R1 we will be getting. In series combination, volume of the liquid flowing across the combination of the tube is, volume of the liquid across the combination of the tube is P by R. R now you can take as in series, here you can take as R1 plus R2 you can take. That means P by here you can take as R1 in the sense here let us take as R you can take. R2 you will be getting as 16 times of the R value. So here you can take as 16 times of the R you can take. So now V dash value you will be getting as, V dash you are getting as here P by 17 R you will be getting. Its P by R is nothing but here initially we are seen as V equal to P by R. So that doesn't mean here you can write as V dash which will be equal to, instead of P by R you have to substitute as V, you have to substitute by 17. So here in the tube length you are going to be reducing in the sense here. So here how much volume is going to be flowing in the sense here, 1 by 17 times of its volume it is going to be flowing across the combination. Now look at the next question. Says a liquid is flowing in a horizontal uniform capillary tube under a constant pressure difference is given as P is given, and here the value of the pressure for which the rate of flow of the liquid is doubled they are given, and here when the radius and length of both of them are doubled. Radius is given as here R2 is given as here 2 times of R1 is given, and here length also it becomes double value is given 2 times of the L1. Now we need to calculate the pressure for which the rate of flow of the liquid is. Here we can take volume of the liquid flowing per unit time, which will be equal to pi by 8 into P R power 4 by, you can write it as eta into L. So here we need to calculate the pressure value. P equals to, you can write it as you just cross multiply this one, volume of the liquid flowing per unit time into E theta into L by, you can take as pi r power 4, you can take. That means here P is directly proportional to, here you can take as V into L by, here r power 4. Here they have given the quantities which is related to the pressure will be, you have to bring P is directly proportional to V into L by r power 4, you can take. Now you just take two values you have to take here, P2 by P1, which you can write it as, it's V2 by V1, this is the volume of the liquid flowing per unit times ratios, into you can write as L2 by L1, into you can write it as R1 by R2 whole power 4, you can take. V2 by V1 is nothing but here the value of the pressure, the rate of flow of the liquid is doubled here. In the second case here volume becomes double is given, initial volume here V you can take, length it has been doubled 2L by L you can take, here radius it becomes 2R, then you can take R by 2R you can take whole power 4 you can take. Here you have to cancel length and volumes, you have to cancel, RR you have to cancel. Then here it says here we will be getting as 2 power 4 is 16. So here 2 2s are 4, here 4 into 1 by 16, here it will becomes 1 by 4. This is a 1 by 4 will be getting. That means here P2 which will be equal to, you can write it as P1 by 4. P1 is nothing but initial pressure difference is given as P is given, that you have to substitute. This is a P by 4 is the correct answer. Look at the next question. The next question says here, we have two capillary tubes T1 and T2. Its length is given as here L1 and L2, and here its radius is given as R1, R2. The rate of flow of water under a pressure difference P through the T1 is given. Across the first tube is given as the rate of flow of water, means volume of the liquid flowing per unit time. It's given as 8 centimeter cube per second. Length is L1 equal to 2L2 and R1 equal to R2 is given. What will be the rate of flow when the two tubes are connected in series? The pressure difference across the combination is same is given as before. So here you are connecting, right, two narrow capillary tubes. Length will be L1 and L2, radius will be R1 and R2. Here you can take volume of the liquid flowing per unit time is, here you can take as V which will be equal to, you can write it as pi by 8 into, here you can take as P r power 4 by E eta into L you can take. Right, this is the initial volume here across the first tube you can take. Now here if tubes after connecting in series, if tubes are connected in series, if tubes are connected in series, then the new volume of the liquid flow which is equal to pi by 8 into, you can take as P r power 4 by, so eta into length, how much it becomes. Initial length you are taken as L1 equal to 2L2. That means here initial length, suppose if I am taken as L, the second length L2, here L1 equal to 2L2. L1 equals to 2L2 means here L2 it becomes now L1 by 2. Now initial length I am considering as L1 equal to L, then L2 equals, here you can write as L by 2 you can write. So here I am just writing as here L plus L1 plus L2, instead of L2 I am writing as L by 2 I am writing. So we can write it as, here it becomes 3 by 2. When it comes to the numerator, here it becomes 2 by 3. 2 by 3 into pi by 8 into P r power 4 by, you can write it as eta into L you can take. The new volume which will be equal to, you can write as 2 by 3 into, here initially it is going to be flowing as, how much volume is flowing is 8 centimeter cube per second, that you have to substitute, which is nothing but 16 by 3 will be getting new volume of the liquid. So here it is 16 by 3 centimeter cube per second you can take. Here in the options is given as centimeter cube, we need not convert. So this will be the correct answer, 16 by 3 centimeter cube per second. The next question says, two capillary tube of same length but a different radii is given as R1, R2 are fitted in parallel to the bottom of the vessel. The pressure head is given as P. What should be the radius of the single tube that can replace the two tubes so that the rate of flow will be same as before it's given. Now here this is the base of the tank you can take. Here you are connecting the two pipes here. This is a tank you can take. Here one should be the radius is given as right, R1 is given. This is one tube we can take. One more tube it's given. Its a length here it's given as here what should be the radius of the single tube so that it can replace the two tubes, so that rate of flow will be same they are given. Here you can take, this is same length is the thing here it's given but different radius it's given. So here you can take somewhat bigger area, you can take this radius. So let us take it as R1 and this radius you have to take it as R2 you can take. Now here some volume of the fluid is going to be flowing across these two tubes. Now you are going to be replacing one more tube instead of these two here, right? One more tube we are going to be replacing like this, right? The pressure head is P. What should be the radius of the single tube? And this radius they are asking, right? Instead of these two tubes, you are replacing one tube. One tube we are going to be replacing. Then volume of the fluid will be same as before it's given. Means here it's a combination of the two volumes you can talk. Here this single tube volume of the liquid which is flowing per unit time, which is replacing this tube by these two tubes is given, so that we can take as V1 plus V2. So here you can take as pi by 8 into PR power 4 by eta into L you can take here, which will be equal to pi into P into R1 power 4 by you can take as 8 into eta into L plus pi by 8 into here you can take as PR2 power 4 by eta into L you can talk. Here in both the sides here P these are all you have to cancel 8 eta and here L also you have to cancel, P eta L you have to cancel. Then what will be left over? R power 4 which we can write it as R1 power 4 plus R2 power 4 will be getting. So the rate of flow, so here the radius they are asking, then R equals to here you can write it as R1 power 4 plus here R2 power 4 whole power 1 by 4 will be getting. So here this will be the correct answer. So here in the options here this answer not given, so none of this is the correct answer. Look at the next question. Says two capillary tube of same length and a radii are in the ratio 1:2 are connected in series. A liquid flows through them is under streamlined condition. If the pressure across the combination is given as 1 meter of the water it's given, the pressure difference across the first capillary tube they are asking. So two capillary tubes of same length is given. Here let us take here are connected in series it's given. Here I am just taking as two capillary tubes of same length is given, but the ratio of the radii will be different. So this is one more capillary tube you have to take. You are connecting in series. So the ratio of the radii will be, so let us take this is R in the sense here the second radii you can take as 2R you can take, and here you will be getting as a liquid is flowing through them in a streamlined condition. The pressure difference across the two extreme ends of the combination is 1 meter of water. So across this one let us take first pipe pressure difference I am taking as P1, across the second tube I am taking as pressure difference will be P2. Across these two endpoints here it's given as 1 meter of water it's given. So here it says here length will be same it's given L1, and here this is also length it's given as L, radii will be different it's given. Let us take this scenario. Here L1 equal to L2 which will be equal to L you can take. That means here R1 by R2 its ratio is given as 1:2 is given. Volume of the liquid flowing per unit time will be P by R will be getting. So here in series combination volume of the liquid flowing per unit time remains constant. Across the first tube how much is volume is flowing, across the second tube also the same volume it's going to be flowing. So here P how it is related to the R value in the sense here if V is same in the sense P is directly proportional to R you can get. Then here R equals to you'll be writing as 8 eta into L by here pi R power 4 will be writing. R, how it is related to the radii in the sense here? R in this case here, it is inversely proportional to R power 4. So here I am just relating the R value as which is directly inversely proportional to R power 4. That means here I can rewrite this one as pressure is directly proportional to R and R is inversely proportional to R power 4 means here therefore I am just taking the relation between the pressure and as well as radii, which is inversely proportional to R power 4. That means here you can take as P1 by P2, which you can take as it is R2 by R1 whole power 4 you can take. R1 by R2 is given as 1 by 2, then R2 by R1 which will be equal to 2 by 1, 2 power 4 in the sense here you can take as 16 you can take. Right, that means here P1 you can get it as 16 times of P2 you will be writing. P1 equal to 16 times of P2. So total pressure difference across the two tubes. So P equals to, you can write it as between the two ends is a combination of pressure difference across the first tube and pressure difference across the second tube. So here pressure difference across the two ends of the total combination is given as 1 meter, it's given, which will be equal to, here you can say P1 plus, instead of P2 you can write it as P1 by 16 you can take. Why? Because they are asking across the first tube the pressure value P1 they are asking. So here when you are taking here 1 which will be equal to 16 P1 plus P1, 17 P1, here you can take, here this is 17 P1 by, you can take as 16, that implies here you can write it as P1 is nothing but 16 by 17 you will be getting, 16 by 17 value nearly will be getting a 0.94 meter will be getting. So this is the pressure difference across the two tubes. So here 1 meter of water on both sides, H rho g when you are taking here, rho g gets cancelled. Here you will be getting as H value will be getting in terms of the water, right? This is 0.94 water will be getting. This will be the correct answer. Look at the next question. Next question says water flows in a streamlined manner through a capillary tube of radius is given as A is given, the pressure difference being P and the rate of flow is given as Q is given. If the radius is reduced to A by 2 and the pressure increases to 2P, the rate of flow becomes, here volume of the liquid flowing per unit time which will be pi by 8 into, you can take as PR power 4 by, you can take as eta into L you can take. So volume of the liquid flowing per unit time, how it is related to the pressure means P into, here you can take as R power 4 you can take. So here you can take as coefficient of viscosity and as well as L you can make it as constants you can take, or constants. Of course pi by 8 is a constant value, then here you can take V2 by V1 which you can write it as P2 by P1 into, you can take it as R2 by R1 whole power 4 you can take. So here pressure difference is given as, here final pressure is given as 2P, initial pressure is given as P is given, R2 by R1, R2 here it's given as A by 2, that's nothing but here it's A by 2, here initial radius is given as A is given, then whole power 4 you can take. So here A gets cancelled, PP gets cancelled, here you can get it as 2 power 4 means 16, 2 by 16 in the sense you will be writing as 1 by 8 you will be writing. That means here you will be writing as here V2 which you can write it as V1 by 8 you can take, that's nothing but here initially it's given as here how much volume of the fluid is flowing means Q volume it's going to be flowing by 8 you can take. So Q by 8 is the correct answer. Now look at the next question. How should the pressure difference be altered so that the rate of flow of the liquid be doubled when radius and length will be the double they are asking. So when the pressure difference is altering, the rate of flow of the liquid will be doubled and here the length will be double they are asking. Means here pressure how many times you have to decreases. Volume of the liquid flowing per unit time is pi by 8 into PR power 4 by, you can take as 8 eta into L. That means here pressure how it is related means here to the volume V into, just cross multiply this one, pressure you have to take directly proportional to V into L by, you can write it as R power 4 you can write. That means here you can write as P2 by P1, which you can write it as this is V2 by V1 into here L2 by L1 into here you can write as R1 power 4 by, you can write as R2 power 4. So final volume here it's given as double, it's given 2V by V you can take. Length also double, it's 2L by L into R1 by R2. So here you can take as R by 2R whole power 4 you can take. RR gets cancelled, LL gets cancelled, VV gets cancelled. Then here you will be writing as 4 by 16 you are getting. This 2 into 2 4. 1 by 2 power 4 means here 1 by 16. So here it becomes 1 by 4. That means here we will be writing as P2 by P1 value will be getting as 1 by 4. And here P2 is nothing but here we will be writing as P1 by 4 will be getting. So here, so final pressure will be the 1 by 4 times of the previous value you are getting. Look at the next question. The next question says water is allowed to flow through a capillary tube of length is given as 10 centimeter and its diameter is given as 2 millimeter and a constant pressure difference of 6.5 centimeter of the water level it's given. If 0.16 liter of the water is flowing in 1 minute, its coefficient of the viscosity they are asking. So volume of the liquid flowing per unit time, which you can write it as pi by 8 into PR power 4 by, you can write it as zeta into L. Then here its coefficient of the viscosity, here they are asking. Coefficient of the viscosity eta equals to, you can write it as, so here pi into PR power 4 into T by, you can take as 8 into V into L you can take. It's nothing but here it's given as pressure difference between the two ends, it's given as here 6.5 centimeter of the water level. Means here you can take as P equal to H rho Z, you have to take pressure at a given depth or at a given distance. Here I am just substituting as pi into here H rho Z you can take into R power 4 into T by, you can take as 8 into V into L you can write. So eta equals here you can write it as pi value will be getting as 3.14. Height is given as 6.5 centimeter. So here all the units you must keep in the CGS unit. Why? Because here all the options is given in CGS system of the coefficient of the viscosity, that is poise. So I am just making this one as here in a CGS system alone. Height is given as 6.5 centimeter. You just make like this. Density of the water value will be 1 gram per cc. G in terms of the CGS system you can write it as 980. R power 4 means here it's given as here diameter is given as 2 millimeter, so radius will be 1 millimeter. So here you can write as 1 whole power 4 you can take 1 millimeter. So here one more thing, here it's given as millimeter. 1 centimeter which will be equal to 10 millimeter, you just converting into centimeters. So 1 millimeter you can write as 10 power minus 1 centimeter. I am just converting the radius in terms of centimeters. So 10 power minus 1 centimeter whole power 4 into time is given as here 1 minute it's given 60 seconds by here 8 into volume of the liquid, this is 0.16 liter, right? You just keep like that only, into here you will be getting as 10 will be getting. Length is given as here 10 centimeter, right? You have to keep like this. So after doing these calculations here eta value will be getting as nearly, so here 0.000937 poise will be getting. So this will be the correct answer. Now here let us discuss about the Stokes and terminal velocity related problems. Here the first question says 2 equal drops of the water are falling through the air with a steady velocity, means terminal velocity is given as 10 centimeter per second. If the drops are recombining to form a single drop, then the terminal velocity they are asking. Terminal velocity, the formula will be in the, according to Stokes law, Vt equals will be taken as 2 by 9 r square by eta into density of the body minus density of the liquid into g you can take. Here terminal velocity, how it is related to the radius of the drop, in the sense here it is directly proportional to r square will be getting. Now here the question is given as 2 equal drops of the water This is one single drop you can take, and this is one more single drop you can take. These are the radius you can take as R and R. Now here the radius it becomes capital R you can take. Capital R you can take. There is a relation between capital R and small r. So here we can take as R equal to, here you can take as n power 1 by 3 into small r you can take. N is nothing but number of drops which you are going to be combining. So capital R, now it becomes here 2 drops I am combining. So here it becomes 2 power 1 by 3 into small r you can take. Then here you can take terminal velocity V2 by V1, which you can take as here R2 square by, here you can take as R1 square. R2 is nothing but big drop you are taking. That's nothing but here you can take as R square by initial drop radius, single drop radius will be smaller. So small r square you can take. V2 by here V1 is given as 10 centimeter per second. R2 here capital R is nothing but here 2 power 1 by 3 whole square into R. This is here R square you can take. This is R square I am taking by R square you can take. Here R square gets cancelled. Then here V2 which you can write it as V2 which you can 2 power 2 by 3 you can take. This is 2 power 2 by 3 into 10 centimeter per second you can take. This is the final terminal velocity. Look at the next question here. The velocity of the ball of the mass m and the density d1, which when dropped in a container, it's filled with the glycerin of density is given as d2, liquid density is given as d2, body density is given as d1 is given. It becomes constant after some time. The viscous force acting on the ball will be. Here a ball if you are going to be taking, so here ball it's going to be releasing in the glycerin. And here what are the forces acting on the body means here weight of the body it will act downwards. Here some buoyancy force is going to be acting upwards. Along with this here a liquid is going to be offering certain resistance. That's a viscous force, that is Fe you can take. The viscous force acting on the ball they are asking. Viscous force here it's nothing but here you can take here. First you can talk about what are the balanced forces, equilibrium condition you can talk here Fb plus here Fe which you can take as mg. Then viscous force Fe which will be equal to, you can write it as mg minus Fb. You know here buoyancy force the formula will be getting as here mg minus. So buoyancy force is nothing but volume of the liquid, volume of the body which is immersing inside liquid into density of the liquid you can take into g you can take. And here F is nothing but here m into g into volume of the body you can write it as here density equals here you can take as mass by volume. Volume is nothing but mass by density of the body you can take into density of the liquid into g you can write. If I am taking as mg is common value, here you can write it as 1 minus here you can write as density of the liquid by you can write as density of the body. So this is the viscous force here, it is going to be acting on a ball. So mg into 1 minus density of the liquid by density of the body. Density of the body glycerin is given as here d2, so mg into 1 minus density of the liquid is given as d2, density of the body is given as d1, so viscous force will be mg into 1 minus d2 by d1. This is the correct answer. The next question says here 2 drops of same radius are falling through the air with a steady velocity, means terminal velocity is given as 5 cm per second. If the 2 drops coalescing, the terminal velocity would be. So here when 2 drops you are combining and this is the radius r you are taking and this is one more radius you are taking as r, and here you are forming like a big drop and this radius will be capital R you can take. And here you can equate the here two things in the sense here there is a relationship will be getting between these 2 drops. Here I am just explaining you here. Volume remains here will be getting as same will be getting after combining. So here you can take as initial volume here which will be equal to final volume you can take, and here initial volume of the 2 drops in the sense here you can take as 4/3 pi r cube of the same thing. Here 2 you are going to be combining. So here finally you are getting as 4/3 pi capital R cube you can take. 4/3 pi gets cancelled. So here you can take as 2R cube, which will be equal to capital R cube you are taking. Then R equals to, here you can take as 2 power 1 by 3 into R you can take. The basic formula when two drops or multiple drops when you are combining, R equal to you can take as n power 1 by 3 into small r you can take. Right? This is the basic formula you be remembered. Now here the question says two drops of the same radius you are going to be combining. Right? Falling through the air with a steady velocity. If the two drops are coalescing, right, combining, then here what is the terminal velocity they are asking. So you know terminal velocity according to Stokes law will be getting as 2 by 9 into r square by eta into will be rating as density of the body minus density of the liquid into g you can take. That means here Vt is directly proportional to r square you can take. Then that doesn't mean here V2 by V1, which you can take as, this is capital R square by you can take as small r square. Capital R is nothing but here you can take as two drops you are combining. So here you will be rating as this value. So here this is 2 by 2 power 1 by 3 whole square into you can take as r square you can take by r square you can take. R square gets cancelled. Then here V2 by V1, V2 you can take here, this is 2 power 1 by 3 whole square means here you can write as 2 power 2 by 3 into initial velocity is given as 5 centimeter is given. So here the answer will be this is 5 centimeter is given. So 5 into 2 power 2 by 3 you can take. 2 power 2 here again how we can write here, 2 square whole power 1 by 3. 2 square means here you can write as 4 whole power 1 by 3 into 5 centimeter per second also you can write. So here third one is the correct answer. The next question says here, what is the velocity of the metallic ball of the radius star falling in a tank of the liquid at the instant which is when it is acceleration is 1/2 that of the freely falling body. The densities of the metal and as well as liquid is given as rho and sigma. So density of the metal body is given and liquid is given as rho and sigma, and the viscosity of the liquid is given as eta they are asking. Now here you can take, if your body is going to be falling or moving across the fluid in the sense, here you can take here weight of the body, it will act downward direction, and here it will be some buoyancy force it will act, and here viscous force due to the liquid it's going to be acting in upwards. Now it is under moving under some acceleration. Then here initially if I am talking in the sense here, so net force F net which will be equal to, so this is mg in downward direction minus here upward force you can take as, so tank of the liquid at the instant when the acceleration is 1/2 of the freely falling body it's given. So here you can take Fe minus, here you can take as mg you can take Fe minus Fd. F net force is given as 1/3 of 1/2 of the freely falling body weight. That's nothing but you can take as mg you can take by 2. mg by 2 you can take, which you can write it as mg minus Fe minus Fb you can take. So here you can say here this is mg by 2 which will be equal to mg minus Fe minus Mb will be getting. Then here you can write this one as, if I am writing instead of m mass equal to volume into density, density of the body it's given as here rho is given. So here rho into, here you can write it as 4/3 pi r cube into g you can take by 2 you can take, which you can write it as, this is also you can write it as mg in the sense here again you can take it as density of the body into 4/3 pi r cube into you can take it as g you can take minus viscous force acting on a spherical body is 6 pi into eta into r into v minus, so buoyancy for the force formula will be getting as here volume of the body which is immersed 4/3 pi r cube into density of the liquid is given as sigma into g will be getting. Now here you have to bring this side. So here if I am taking as minus 6 pi eta into r into v plus, here if I am taking common on the right side, So here 4/3 pi r cube, if I am taking common, here it will be rho minus sigma I will be getting here, and here I am taking common. So minus value I am just taking this side here, which will be equivalent to rho into, here you can take as 4/3 pi r cube into g by 2 you can take. Here on both sides you have to cancel. So what will be left over in the sense here, if I am taking common here, minus 6 pi eta rv, and here among these two here if I am taking as common, and here you will be getting as 4/3 pi r cube. If I am taking common here, you just bring this side here, this rho value you just bring this side. This is rho minus sigma into 4/3 pi r cube minus this value I am just bringing this side. So it's rho minus sigma, so which I have taken already common, minus here you can take as rho into it's 4/3 pi r cube by 2 you can do, which you can write it as 6 pi into eta into r into v you can take. Now if I am taking common 4/3 r square into, here pi you have to eliminate on both sides, 4/3 r square into g if I am taking common, here it becomes here rho minus rho by 2, here it becomes rho by 2 will be getting, minus sigma will be getting, which will be equal to 6 into eta into, here one r also you have to cancel here, I am just taking as r square, and here r square you have to take after removing this r value. This is v you can take. Then the terminal velocity they are asking, v equals to, you can write by solving this one, here you can write it as 9 eta into, here we will be getting as rho minus 2 sigma whole into, here we will be getting as r square into g will be getting. So this is a velocity formula. So 1 by 9 eta into r square g, right, rho minus 2 into sigma will be getting. So this will be the correct answer. Now the next question we just look at, a metal ball of radius r and density is given as d, and here it travels with a terminal velocity v in a liquid of density is given as d by 4. The terminal velocity of another ball of radius 2r and the density 3d in the same liquid they are asking. So you know terminal velocity formula you can write it as 2 by 9 r square into r square by eta into density of the body minus density of the liquid into g you can take. That means here Vt is directly proportional to, here you can take as r square into density of the body here minus density of the liquid you can take. So here in the first case, here it's given as, here I am just taking the ratio v1 by v2, which will be equal to ball radius is given as r, the next ball radius is given as 2r is given, so that here you can take as r1 square by r2 square you can take. So density of the body minus density of the liquid in the first case you can take by density of the body minus density of the liquid in the second case you can take. Here you have to substitute these values, and here v1 by v2, these two are the terminal velocities ratios. r1 by r2, initial radius will be r, that means here r by 2r whole square you can take. So density of the body, how much it is given initially here, d is the density of the body. It is flowing across the two different liquids. One density is d by 4, another density is given as 3d. So density of the body is not changing, density of the liquid alone it's going to be changing, d minus d by 4 by, so here you can write as 3d minus d by 4. Density of the liquid is not changing, density of the liquid is not changing, density of the body alone it's going to be changing. Now here you have to simplify this one. Here we will be writing as v1 by v2, which you can take as, it's nothing but 1 by 4, here rr gets cancelled, and here 4d minus d, here we will be getting as 3d by 4 you are getting. So 4 3 is 12 minus 1 11, so here we will be getting as 4 by, you can take as 11d you can take. So dd gets cancelled, 4 gets cancelled, here we will be writing as this is 3 by 4 into 11 will be 44 will be getting. That means here the final terminal velocity which will be equal to v2 equals to, here you can take as, you just cross multiply this one. or else you can write as V1 by V2, which you can write it as 3 by 44. That doesn't mean. So here they are asking V2 value, V2 equal to 44 by 3 times of initial terminal velocity. We will be getting 44 by 3 into V. That will be the correct answer. Look at the next question. The next question says a steel ball of mass m falls in a viscous liquid with a terminal velocity 4 meter per second. If the another ball of radius is 8 meter falls through a same liquid, then its terminal velocity they are asking. So terminal velocity formula will be writing as 2 by 9 into r square by eta, density of the body minus density of the liquid into g you can take. That doesn't mean here masses they are talking here. In this question, they are talking about the mass. Initial mass is given as m and final mass is given as 8m is given. Vt, when you are relating to the r value, it becomes r square. Mass equals to, here you can write it as volume into density. Volume of the sphere steel ball it's given, it will be in the spherical shape. 4/3 pi r cube into, you can write as rho is the density you can take. That doesn't mean m is directly proportional to r cube will be rating. That means r is directly proportional to m whole power 1 by 3 will be getting. M whole power 1 by 3 when you are taking 1 by 3 whole square you can take. So now I am just relating the terminal velocity with the mass. It becomes m whole power 2 by 3. The new terminal velocity they are asking. So here you can take as v2 by v1, which you can take as m2 by m1 whole power 2 by 3 you can take. m2 is given as here 8m is given, initial mass is given as m is given, whole power 2 by 3 you can take. mm gets cancelled. v2 by initial velocity is given as 4 meter per second, which will be, so this one you can write it as 2 cube we can write, whole power 2 by 3, 3 gets cancelled, 2 power 4, this becomes 2 power 2 square. So 4 4s are will be getting a 16 will be getting. So the final terminal velocity will be 16 meter per second will be getting. So this will be the correct answer. Look at the next question. The next question says two metal spheres of densities is given in the ratio 3:2 and the diameters are in the ratio is given as here 1:2 is given. You are releasing from the rest in two vertical liquid columns of the coefficient of the viscosity is given as 4:3. If the viscous force acting on them will be given as same is given, then we need to calculate the ratio of their instantaneous velocities. Here that's nothing but here we can talk about here velocities they are asking. If two metal spheres when you are releasing in a liquid from the rest, the viscous force experienced by the body formula will be Fv equal to, according to the Stokes, 6 pi into eta into r into v you can take. That means here if the viscous force acting on the two bodies is given as same is given, 6 pi of course is a constant value. Now we just relate these three factors, eta into r into v, which you can take as constant you can take. That means here velocity which is inversely proportional to the coefficient of the viscosity and as well as radius will be getting, which means here you can write as v1 by v2 when you are taking, which you can write it as eta 2 by eta 1 into here you can write as r2 by r1 you can take. Coefficient of viscosity relation eta 2 by here ratios is given as eta 1 by eta 2 is given as here 4:3, but we require eta 2 by eta 1, here you can write as 3 by 4 you can talk. 3 by 4 into here ratio of the radii, here diameters ratio is given 1:2. 1:2 if you are taken as r equal to d by 2, r1 equal to d by 2, r2 equal to d by 2, by 2 gets cancelled. Only here ratios of the radii you can take, r2 by r1 you can take as it's 2:1 you can take. So 2 2s are, and here we will be getting as v1 by v2. It is the ratios they are asking, v1 by v2, which you can write it as this is 3 by 2 will be getting. This is the ratios of the velocities. The next question says here a solid rubber ball of density is given as d. It's given as d and radius r. It falls to the air. Assuming that air resistance acting on the ball will be krv, where v is the velocity of the ball and k is a constant. The terminal velocity attained by the ball 1 they are asking. So here the viscous force or as the air resistance is nothing but here viscous force acting on the body. F is nothing but here it's given as K into R into V is given. The terminal velocity at end, here both the velocities are equal. Sorry, weight of the body, if it is going to balancing the viscous force, weight of the body if is balancing the this viscous force is given or air resistive force is given, then we can attain the terminal velocity. So F is nothing but mg you can take, which is nothing but K into R into V. So here V is given as, here velocity is given, here mass is nothing but here you can take as 4/3 pi into, here you can take as R cube you can take, it's a density you can take as D into G you can take, this is nothing but K into R into V you can take, here one R and here one R gets cancelled, then velocity which will be equal to you can take as 4/3 into pi into R square D into G by 3 times of, here we will be getting as K will be getting. So this is the terminal velocity of the ball.